Imagine this. Right now, while you're watching this video, something unimaginable is hiding at the very center of our galaxy. 26,000 light-years away beyond billions of stars, there exists an object so powerful that not even light, the fastest thing in the universe, can escape its grip. Its name is Sagittarius A star, a supermassive black hole containing the mass of 4 million suns compressed into a region smaller than our solar system. And today we're going there. Not to observe it from a safe distance, not to study it through a telescope. We're going to fall directly into it, step by step, meter by meter, all the way to the edge of reality itself. What would you actually see? Would you be torn apart instantly? Could you survive crossing the event horizon? Would time stop? Would the universe end? Or could a black hole become a doorway to somewhere else entirely? What you're about to hear is not science fiction. Everything in this journey is based on the best physics humanity currently understands. And some of it is far stranger than anything Hollywood has ever imagined. So buckle up, our ship is ready. The destination is the most dangerous place in the Milky Way, and once we begin, there is no turning back. The engines ignite, Earth disappears behind us, days become months, months become years. Our spacecraft travels across unimaginable distances, crossing vast rivers of stars and clouds of cosmic dust. Eventually, after a journey that would take tens of thousands of years with today's technology, a dark shape begins to emerge from the center of the galaxy. At first, it doesn't look like anything special. That's because black holes are invisible. They emit no light, they reflect no light. You cannot see a black hole itself. You can only see what it does to everything around it. And what Sagittarius A star does is terrifying. As we move closer, the stars behind it begin to distort. Light bends, space twists. The black hole acts like a giant cosmic lens. Entire constellations stretch and curve around a region of absolute darkness. This effect is called gravitational lensing. Einstein predicted it more than a century ago. And now we're witnessing it firsthand. The closer we get, the more bizarre reality becomes. Stars that should be behind the black hole suddenly appear above it. Others appear below it. Some appear multiple times at once. It's as if the universe itself has become a broken mirror. But this is only the beginning, because ahead of us lies one of the most violent environments in existence, the accretion disk. Imagine a gigantic whirlpool of gas, dust, shattered planets, and dying stars orbiting the black hole at nearly the speed of light. Friction heats this material to millions of degrees. The disk glows brighter than billions of stars combined. If your spacecraft lost its shielding here, you would be vaporized instantly, not burned, not melted, completely transformed into plasma. From a distance, the disk resembles a blazing ring of fire wrapped around pure darkness. But something strange catches your eye. The top of the disk appears above the black hole, and below it at the same time. How is that possible? The answer is mind-bending. The black hole's gravity bends light so dramatically that you can actually see the backside of the disk wrapped over the top like a cosmic halo. You're not seeing an illusion. You're literally seeing light that has traveled around the black hole before reaching your eyes. Already, the laws of everyday reality are beginning to break down, and we're still far away. Now imagine looking back toward Earth. Something impossible happens. The clocks on Earth seem to speed up. Days pass in seconds. Years flash by like moments. This is gravitational time dilation. The stronger the gravity, the slower time flows. Near Sagittarius, a star, your clock and Earth's clock no longer agree. To you, only a few hours may pass. But far far away, years could unfold. Civilizations could rise and fall while you simply watch. Entire generations could be born and disappear. And the closer we get to the black hole, the more extreme this effect becomes. Eventually, 1 hour for us could correspond to years for people back home. Think about that. You leave Earth for what feels like a short mission. You return. Everyone you've ever known is gone. History has moved on without you. The black hole hasn't just changed space, it has changed time itself. Ahead lies the photon sphere, one of the strangest places in the universe. At this distance, gravity becomes so intense that light can orbit the black hole. Photons, particles that normally travel in straight lines across the cosmos, are forced into circular paths. And here something truly bizarre happens. You glance forward, then you glance to the side, then behind you. Every direction begins showing distorted versions of the same universe. Light circles the black hole multiple times before reaching your eyes. In theory, if you looked carefully enough, you could see the back of your own head. Not through a mirror, not through a camera, but because your own light has traveled around the black hole and returned to you. You are literally seeing yourself from behind. Physics has become surreal, yet the worst is still ahead. The event horizon, the point of no return, the invisible boundary beyond which escape becomes impossible. Cross it, and every path through space and time leads only one way, deeper, toward the center, toward the unknown. From a safe distance, the event horizon seems ordinary. No wall, no gate, no glowing barrier, just empty space. But once crossed, the fate of everything inside is sealed forever. And here's the shocking part. If Sagittarius A star is large enough, you might not even notice the exact moment you cross it. No alarm sounds, no explosion occurs. The universe outside continues to look almost normal, at least for a little while. But physics tells us something terrifying. Even though you may not feel it yet, you are already trapped, completely, forever. And now our journey enters a region where no human, no probe, and no signal could ever escape to tell the story. What happens next remains one of the greatest mysteries in all of science. The moment we cross the event horizon, something extraordinary happens. Not to us, but to the rest of the universe. If someone far away were watching our ship, they would never actually see us enter the black hole. From their perspective, our image would appear to slow down more and more. The light leaving our spacecraft would become increasingly red, increasingly faint. Seconds would stretch into minutes, minutes into years. Eventually, we would seem frozen forever on the edge of the event horizon, a ghost trapped in time. But from our perspective, the story is completely different. We continue moving forward. Nothing stops us. Nothing blocks our path. The event horizon is not a physical surface. It is a boundary written into the geometry of space-time itself. Now we are beyond it. There is no turning around. No amount of fuel could save us. No engine ever built could reverse our course. Because inside a black hole, the rules of reality change in a way almost impossible to imagine. Outside the horizon, moving toward the center is a choice. Inside, it becomes your future. Just as tomorrow inevitably follows today, reaching the center becomes unavoidable. And this is where physics becomes truly terrifying. Space and time begin to exchange roles. Outside the black hole, you can choose where to move in space. Forward, backward, left, right. But you cannot choose whether to move into the future. Time carries you forward whether you want it or not. Inside the event horizon, the situation reverses. The singularity becomes part of your future. Not a location you can avoid. A moment you must reach. Trying to avoid it would be as impossible as trying to avoid tomorrow. Every possible path leads there. Every road ends at the same destination, the center, the singularity. But what exactly is a singularity? According to Einstein's equations, it is a point where density becomes infinite, where gravity becomes infinite, where the known laws of physics completely break down. Our best theories simply stop working. It is a place where mathematics itself begins to fail, and yet we are moving toward it, faster than ever. At first we notice something strange. The stars outside begin disappearing. One by one, the visible universe shrinks into a small, bright circle above us. Everything else becomes darkness, not because the stars are gone, but because their light can no longer reach us. The black hole is slowly cutting us off from the rest of existence. The universe we've always known is fading away. Soon, only a tiny glowing window remains, a final view of creation itself. Then even that begins to vanish. And now another danger emerges, a danger with one of the strangest names in science: spaghettification. It sounds ridiculous, but it may be one of the most horrifying deaths imaginable. Black holes do not pull equally on every part of your body. The closer a part of you is to the center, the stronger gravity becomes. Your feet experience more gravitational force than your head. This difference is called a tidal force. Near smaller black holes, tidal forces become extreme long before reaching the event horizon. Your body would begin stretching. Bones would break. Organs would tear apart. Atoms themselves could eventually be ripped from one another. You would be transformed into a thin stream of matter, millions of kilometers long, like cosmic spaghetti. Fortunately, or perhaps unfortunately, Sagittarius A star is so enormous that these tidal forces near the event horizon are relatively gentle. You can survive crossing it for a while. But deeper inside, the forces become stronger and stronger. Eventually, not even molecules can resist them. Everything that makes you you is pulled apart. Every cell, every memory, every thought, reduced to fundamental particles falling toward the unknown. And yet, according to quantum physics, another mystery appears. What happens to the information contained within you? Physics contains a strange rule. Information cannot simply disappear. The exact state of every particle should always remain encoded somewhere. But black holes seem to destroy information completely. Objects fall in. The singularity consumes them, and nothing comes back out. This contradiction became known as the black hole information paradox, one of the greatest scientific mysteries ever discovered. The famous physicist Stephen Hawking believed black holes slowly evaporate over immense periods of time. Through a process now called Hawking radiation, over trillions upon trillions of years, a black hole can gradually lose mass, eventually disappearing altogether. But if the black hole vanishes, what happens to everything that fell inside? Where does the information go? Is it destroyed, hidden, stored somehow on the event horizon itself? Even today, some of the smartest minds on Earth continue searching for the answer, because solving this puzzle may reveal something even deeper, a theory that finally unites gravity and quantum mechanics, a theory of everything. But there is one final possibility, one that sounds like pure science fiction. What if the singularity is not the end? What if it is a doorway? Some solutions to Einstein's equations suggest the existence of wormholes, tunnels connecting distant regions of space-time, a shortcut through the universe. These hypothetical structures are known as Einstein-Rosen bridges. If such a bridge could remain stable, it might connect two different locations, two different galaxies, perhaps even two different universes. Imagine falling into a black hole and emerging somewhere else entirely. A newborn cosmos, another dimension, another reality governed by different laws of physics. No evidence currently proves this happens. In fact, most calculations suggest any wormhole would collapse almost instantly, too quickly for anything to pass through. Yet the possibility remains fascinating, because it reminds us of an extraordinary truth. Black holes are not merely objects, they are questions. Questions about space, questions about time, questions about the nature of reality itself. And so our journey comes to an end. The stars are gone, the universe has vanished from view. Ahead lies the singularity, a destination where every known law of physics reaches its limit. What happens next? The truth is, nobody knows. Not Einstein, not Hawking, not the greatest scientists alive today. Beyond this point, our equations fall silent. And perhaps that is the most astonishing discovery of all. At the center of the darkest objects in the universe lies a mystery so profound that humanity still cannot explain it. A place where reality itself appears unfinished. A reminder that despite all our knowledge, we are still explorers standing at the edge of the unknown. And somewhere, 26,000 light-years away, Sagittarius A star continues waiting, silent, invisible, patient, guarding secrets that may one day completely transform our understanding of the cosmos. Until then, the greatest journey in the universe remains unfinished.